2.2, we're still talking about frequency distributions and their graphs, but now we're talking about quantitative data, so measuring counts, numbers. Frequency distribution is divided into classes, so 1, 2, 3, 4 classes. What's important is the classes go up by your class width this way. So 0 plus 5 is 5. 4 plus 5 is 9. So they go up that way by the width. That's always standard. To get your class width could depend on the problem, but always should be that way. Notice they're always consecutive from classes 4 to 5, 9, 10. These are your lower class limits. So on your first class, 0 is the lower class limit, and 4 is the upper class limit. On the second class, 5 is the lower, 9 is the upper. The lower class limit of the class is the smallest value that can appear in that class, and it should cover the entire range of your data, and nothing would be missing, so everything has a space to go. So when you're choosing your classes, everything's got to fit into a class. You can't have any overlap, and they all go up by the same width, and there's no gaps or overlaps, and it covers your data. Constructing a frequency distribution of quantitative data, here's some instructions, but it can depend on if you begin with what they tell you to use as the width, or maybe they'll tell you the number of classes to use when constructing it. So for example, we have these 32 ages of participants at a retirement seminar, but we're told to use a class width of 6. So you're going to find the smallest value, and then you're going to add 6 to that to get the lower limits. So I'm starting with the smallest, 48. I'm going to add 6 to it, and I'm going to keep going up, and then here we get to 72. Well, my largest value is 74, so I'm going to need to go past 72. So the next, if I add 6 to 72, would be 78, so that has to be 77. Notice these also go up by 6, 6, 6, 6. So I could get the 77 that way as well. And then you count how many people on that chart were between the ages of 48 and 53. Well, there's 3 of them. 3 out of the total 32 is the frequency of the first class. And then you fill in the rest. And this total is going to add up to the whole 32, my sample size. Everybody's accounted for on the frequency distribution. These are my lower class limits, upper class limits. My class width is 6. It's also 6 here as well. And here, same frequency distribution. And this, we just added the relative frequency column, which is the frequency in that class divided by my total sample size. So 3 divided by 32, rounded to 3 decimal places. This histogram doesn't exactly match that last frequency distribution, but it's close. But it's just an example that, if you notice, because there's no space in between the classes, that there's no overlap and there's no gap. The difference between a bar graph and a histogram is that they touch. Your histograms can be labeled with their lower class limits or your upper class limits. These are labeled with the lower class limits, so you can look at a histogram and see what the class width is, because it goes up by the class width. And this displays the frequency of the number of people in each class. 1, 2, 3, 4, 5 classes. Shapes of a data set. So a histogram gives a visual impression of the shape of a data set. So there's some terminology to label them. If you have a histogram like this with a center and a mirror image on each side, it's symmetric. Now, lots of them aren't going to be perfectly symmetrical, but they could be approximately symmetrical. If your histogram, has a long tail. So if it has a tail, it's called skewed to the right or to the left in the direction of the tail. Now, this is skewed to the left. Why is it next to the right? Because that's a typo, and I'm not going to redo this video, but I will be redoing the notes, so you will have the proper notes. So this tail is skewed to the right, so it goes in the direction of the tail. This is skewed to the left. The tail is going to the left. So like I said, I will be fixing these on the notes, but the skew goes the direction of the tail. And if a histogram has approximately the same number in each class, then it's said to be uniform. If a histogram has a peak or a high point, its mode, its most frequent, right? It would be the highest number in that class. So this picture is a unimodal histogram. It does have a mode, and this one clearly has two modes, so it's bimodal. The class midpoints are used to calculate approximate mean. They're used to label the histograms, and what it means is what's the middle number or the average number of each class. That's what the midpoint is going to be. Now I will say this, it depends on your text. You can find the class midpoint by adding these lower limits and the upper limits and taking the average of it divided by 2, or some texts will have you do 48 plus 54 divided by 2 using the lower limits, adding these up divided by 2, add these up divided by 2. Either is fine. It depends on the text that you're using or the software that you're using, so check to make sure what they want. So some of the graphs are going to use information on your frequency distributions. Frequency polygon uses the frequency in each class and the midpoint. So above the midpoint, it's at that frequency, and for the next one, it'll go up to the 9 and so forth, up and down, looking at the frequency in each class. An ogive is a picture of the cumulative frequency. Cumulative frequency is when you take the frequency in each class and add it cumulatively as you go down. So in the first class, there's only 3. Between the first and second, I do 3 plus 9 to get 12. Between the first, second, and third, I'm going to do 12 plus another 12 will be 24, and so forth, and I'm going to end up at my total sample size, 32. So it kind of goes up like a staircase and ends at your total sample size. But I'll repeat this. To find the cumulative frequency, you add the frequencies in each class as you go down onto each other till you get to the total.